Hello, ladies and gentlemen, and thank you for welcoming us here at the NILM workshop today. We are, as Jack said, a group of MSc Computing Science students here at Imperial College London. And again, as we said, in the spring term, we undertook a 3-month group project, which we decided to do in the field of energy disaggregation. This was a field in which none of us had any prior knowledge, but it was one we thought offered us, well, had potential for a really interesting project that we could really get our teeth into. So why did we choose energy disaggregation? Well, as I'm sure you're all aware, interest in the field has never been higher. I believe you've already seen this graph earlier in the day, but this graph shows an explosion in the number of citations of George Hart's 1992 paper in publications in the field, considered one of the first publications on energy disaggregation. But again, as Jack said, one of the biggest problems is that there is no gold standard by which you can compare the performance of one algorithm against that of another. And this is a real problem because it does make it very difficult to ascertain whether we're going in the right direction, how much progress has been made, whether we're reinventing the wheel even. So we aimed to come up with a tool, an online benchmarking tool, which would provide some sort of standardized score, which would enable the direct comparison of one algorithm against another. So briefly how it works is that we provide a private data set. It's private so that we can be sure that no algorithm has seen it before. And on that note, we decided not to provide a training data set as we worried about the overfitting of algorithms. So we provide users with a private data set which they can run on their own system. They run their own algorithm against it, and then they submit to us their results. And we use that, we compare that against the ground truth data to generate a score. And this is our idea of our attempt at solving the problem that Jack has just outlined. So as we say, it's a relatively transparent scoring process, which Sean and Stefan will talk to you more about later on. But we're hoping to be an impartial adjudicator and provide a genuine contribution to the problem of comparing energy disaggregation algorithms. So I'm now going to invite Aisling up to join me, and we'll give you a little demonstration of how the system works.
So as Frankie said, we're just going to give you a quick demonstration of how you might use the website, hopefully at some point. So this is what it looks like when you are not logged in. And at this point, there are some pages which you can access, like account settings. But you can access pages that just give you general information on how the website works and the scoreboard. So the rules page basically outlines how we hope people might interact with the system. And we did have time to implement some sort of anti-cheating protocols, but in general, we're hoping that people will act in good faith when using the system because it is a research tool. And we also just say that we don't really mind who uses the website. There's no restrictions on teams or anything like that. And we also provide links to some publicly available databases that you might already be familiar with.
So once a researcher has created an account, the first thing for them to do is log in. And when they do so, they will see a personalized view of the homepage, which will provide them with a little summary of the type of algorithm they're using, when they last downloaded data, when they last uploaded data, and what score their latest submission received. So one other thing they can do when they're logged in is visit the settings page, where they can provide more information about the type of algorithm that they're using. At the moment, we're not really doing much with this information. You can see that we're asking for the algorithm type. This is information that at the moment we're collecting, but we're not actually acting on. The main reason for this is that we were worried about what we call the fragmentation of results. So we were worried that if we divided algorithms up by algorithm type, actually each algorithm would end up in a ranking of its own, which would completely just defeat the point of comparing algorithms. So for the time being, we're not doing anything with this information. But if anybody has any ideas about what might be useful in that respect, then please let us know. You can also elect on the settings page to appear anonymously. We were conscious that some users of the site might be worried about commercial sensitivity of their algorithms and their performance, or for other reasons might wish to appear anonymously on the scoreboard. All algorithms that are used on the GreenGauge site will appear on the scoreboard so that other users can gain an idea of how they're performing against others. But as I say, if you do not wish to have your team name appear next to that score, it can appear anonymously.
Great. So if you actually want to use the system and you're logged in and you've told us some things about your algorithm, you go to the download data page. So this basically just tells you what file you're going to be downloading, which is a zip.csv file. we decided that we weren't going to implement any limits on how many times or how frequently you can download the testing data, but there is a record here which just tells you when you last downloaded it and how many times you downloaded it. So basically the idea is that you would download the data and run your algorithm on it on your own system, and Sean will talk about why we chose to do it this way later.
So once you have run your algorithm on the data we've provided, the next thing to do is upload your results, which you can do on this page. There are some limitations on the way in which uploads must appear. So they have to have the correct file name and be of the correct file type. If you submit something that contravenes either of those rules, you will get an error warning. And if you accidentally submitted a file which passed those checks but was complete nonsense on the inside, you would get an error message later on. One thing to note is that submissions are limited to 1 a week. This is, as Aisling mentioned, one of our attempts to discourage fraudulent use of the site or attempt to defraud the system by, for instance, people bombarding the site with submissions in the hope that one of them will hit close to the ground truth data. So we have limited it to 1 a week.
So having uploaded your results, you will then receive an email to the email address you registered with, which contains an overall score and a score for each appliance, which is listed here. Then, in addition to this, you can now go to the scoreboard to see where your entries appear. So as we've said, you can anonymize, so you can choose not to have your team name appear. But once you're logged in, any entries by your account will appear in bold, and they're ranked by the mean squared error, which Stefan will talk about. So I'm now going to hand over to Sean to talk about the architecture of the website and the data.
Hi. So I just wanted to give a brief overview of how we organize the site. So here's just a simple site map. It's not a lot of web pages that comprise of the site, and we just use a Apache server to serve up the web pages. The API that's doing the rendering is all in Python. We just use a SQL database to store the results, and the metrics are all calculated just using Python scripts. So it's all pretty simple. So I wanted to talk to you about a couple of the design choices we had to make regarding how to handle data. We had to think about what we were giving to you guys to disaggregate. We had to think about whether we were going to provide some training data. And we also wanted to think about what we wanted back from you guys as a result. So because our project was quite short in time, we had to create an aggregate energy data. And this was just basically recombining individual appliances signatures from the UK DAL set. This isn't ideal. I mean, if you were to launch the website fully, you'd probably want to collect a private real-world data set, change the website. Other things that we thought about, so if you were to develop the platform further, is whether you wanted multiple data sets, so depending on different use cases, so a data set that came from industry or a home or different types of scenarios, so people making algorithms for those scenarios could get better metrics. But with that comes that we also have to think about how many data sets we make available, because as you do this, because we want to maximize how many scores we can compare against each other. And if you're running your algorithms in different data sets, then that you obviously can't compare those scores. So the next thing we had to think about was training data. We decided not to supply any training data based on we were worried about overfitting, algorithms overfitting to our data. And there was also some implementation issues. But overall, we thought that algorithms that didn't need training data were less intrusive and would probably be more applicable in real world scenarios. So that was that thought process. And then the next thing we had to think about was what we wanted back from you guys in terms of results. So on the results page, we give you a list of all the appliances that are in the aggregate signal. But in the future, you might want to hide this. We might want to hide this, and then we could come up with a metric on how well your algorithms are able to tell which appliances are in the signal. And I mean, with that, you would obviously need a sort of a standardized vocab to allow the system to be compatible. But I mean, overall, we sort of kept things very simple. All the data is handled in just a CVS file, and it's pretty straightforward to use. I'm just going to hand it over to Stefan, who's going to talk about a bit about the metrics that we used.
This is nice. We're not being assessed this time. So this is quite relaxing. I'll go straight to the point. We just used a simple mean squared error for assessing users' performance. This is due to our lack of deep knowledge in this field, and generally in science, it's a very well accepted universal standard of measuring performance. Especially in this case, we want to measure the deviation between our ground truths and the results that users submit. Having said this, we are aware that this is far from ideal. I mean, let us just explore this diagram on the side, and let us consider the simplest possible scenario. A user submits a signal that is always off, 0 power, and no algorithm, nothing. And let us consider different metrics. We can see that, well, this is the dark green on the far left. Using some metrics, this is a very high performing result. Using other metrics, it is terrible. And well, we know that it's just nonsense because no algorithm was ran. So again, we don't really know. We have no answer for this issue. This is where your involvement comes in. And we hope we've provided a, transparent online tool for everyone to use so that a general consensus can be arrived to, and we can tailor it to your needs. So in a nutshell, Green Gauge provides a means of direct comparison between different algorithms. This is just a prototype, but we see the huge potential that this field has. So we really hope that this tool can be useful to everyone in the room and everyone else to maybe take the field a bit further. But then again, we need your involvement and your feedback for this. Any questions?